Polygons 8.2. A polygon is a closed figure in a plane determined by 3 or more straight line segments. So anything that is made up of line segments that's closed together, it's a polygon. So it needs to have at least 3 sides. Doesn't matter what it looks like, it just has to be all connected and all have sides. That's a polygon. The straight line segments that form the polygon are called its sides, and a point where 2 sides meet is called a vertex, plural vertices. The union of the sides of a polygon is the interior end, and its interior is called a polygonal region. A regular polygon is one whose sides are all the same length and whose interior angles will have the same measure. Polygons are named according to their number of sides. So 3 sides triangle, 4 sides quadrilateral, 5 pentagon, 6 hexagon, 7 heptagon, 8 octagon, 9 nonagon, 10 decagon, 12 dodecagon, and 20 isosagon. Sum of measures of interior angles. The sum of the measure of the interior angles of an n-sided polygon is n minus 2 times 180. So say I had a quadrilateral and I want to figure out what do all of the insides equal. Like if I added it all up, what is it going to equal? And this is the formula you would use. So n, that's the number of sides. Angles of a regular decagon. A regular decagon is a 10-sided figure with all sides having the same length and all interior angles having the same measure. Determine the measure of an interior angle and the measure of an exterior angle. So we need to find the measure of an interior angle. So to find the measure of an interior angle, we need to figure out what does it all equal on the inside first. So to find that, we use our formula of n minus 2 times 180 degrees. And remember, n is the number of sides. So this is a 10-sided figure, so our n is 10. Let's plug it in. We have 10 minus 2 times 180 degrees. So that's 8 times 180 degrees. That means that's 1440 degrees. All of it on the inside, all of it together is 1440. Every single angle put together is 1440. But now we only want to know the measure of one interior angle. So to find the measure of one interior angle, how we find that, it's always going to be your total divided by your n. So our total was 1440, and we're going to divide that by how many sides we have, which is 10. So 1440 divided by 10, and we get 144 degrees. So that means each one of these angles is 144 degrees, every single one of them. Because this is a regular polygon, meaning all the sides and all of the angles are the same. All right, now we want to find the exterior angle, outside angle. So we're trying to find this one right there. When there is an exterior and interior angle next to each other, they are supplementary. So meaning when you add them together, it equals 180. So when you add the interior angle and you add it to the exterior angle, they're going to equal 180. So we know our interior angle. It was 144 degrees. We don't know our exterior angle, so we say that's x, and it's going to equal 180. So we can solve by subtracting by 144, and when you subtract by 144, we get x equals 36 degrees. So that means this little angle, angle 1, is 36 degrees. Types of triangles. Acute triangle, all angles are acute, meaning less than 90. Obtuse, one angle is obtuse, meaning one angle is more than 180 or more than 90. Right triangle, one angle is right angle. Isosceles, two sides and two angles are equal. Equilateral, everything's equal and each are 60 degrees inside. And a scalene, nothing's equal, it's just a wonky triangle. Similar figures. Two figures are similar if their corresponding angles have the same measure and the lengths of their corresponding sides are in proportion. Similar figures. So similar figures are proportionate, so we can work with them together. We want to find the length of BC and then PQ. So we want to find the length of BC. That's here. So whatever you need to find, you put it first. And remember, proportions are fractions. So whatever you need to find goes first. Then we match it up with what it has in common to the other figure. So BC correlates to QR. Right here. It correlates to QR. Then you put what's known. So since BC is on top, that's the little figure. That means top has to be first. So if we look at the little figure, we have two values, A to B and D to C. But if we look at the big one, we don't have the A to B side. We have SR, which is the similar to DC. So we're going to use SR and DC. Since BC is on top, and that's from the smaller figure, we're going to put DC on top first. Small goes with small, big goes with big. So you see how on the top we have the small figure, all of those dimensions, and on the bottom we have the large figure, all of those dimensions. So let's plug it in. BC, we don't know, it's X. QR, that's 3. All right, and then we have DC, which is part of the smaller figure, which is 3, and SR, which is the bigger figure, and that's 4.5. So with proportions, we always cross multiply. So we have X times 4.5, that's 4.5X. 3 times 3, that's 9. We divide by 4.5. And we get X equals 2. That means BC equals 2. All right, that was part A. Now let's do part B. So since we already have numbers worked out, you should reuse them. Reuse the numbers you've already used. So for BC, we need to find PQ. So PQ, that's the larger figure first. So whatever you need to try to find, you put it first. So that's PQ. And since these are similar figures are always proportionate. So do you notice now we have large on top? So it's actually backwards now. We have large on top and small on bottom. So we want to keep with that format. So something that has to do with PQ, well, we have that value. It's actually right here. PQ similar to AB. And then use what we already used. So we already used DC and SR, use it again. But we have to have large on top, so we'll have SR over DC. So PQ, we don't know it. They say it's Y. Over AB. AB is 4. And that equals SR, which is 4.5, over DC, which is 3. And we cross multiply. We get 3y equals 4.5 times 4, which is 18. Divide by 3. And we get y equals 6. That means PQ equals 6. Example 3. Monique plans to remove a tree from her backyard. She needs to know the height of the tree. Monique is 6 feet tall and determines that when her shadow is 9 feet long, the shadow of the tree is 45 feet long. How tall is the tree? So these are similar figures. I'll draw them out so we can really see those two figures. So we have two figures that are similar. We want to know the height of the tree. The height of the tree. So that's what we need to find out first. So that's what goes on top, height of the tree. So we have height of the tree. Now we have to have something that correlates to the height of the tree. Well, we know the height of Monique. Because those are the corresponding sides. And that's going to equal, so on top, do you notice we have tree on top? And on the bottom, we have Monique. So that means when we do the numerator, we want to keep with the tree, and the denominator, we want to keep with Monique. So let's know something else about the tree. Well, something else about the tree we know is the shadow of the tree. The shadow of the tree is 45 feet long. So that's the shadow of the tree. Now, if we know the shadow of the tree, because Monique is in the denominator, we need to know the shadow of Monique. And we do know the shadow of Monique. It's 9 feet. So let's put in our numbers. We don't know the height of the tree. That's x. The height of Monique is 6 feet. And that's going to equal the shadow of the tree, which is 45 feet, over the shadow of Monique, which is 9 feet. We cross multiply because these are similar figures. We get 9x equals 270. Divide by 9, and we get x equals 30. You don't have to write it as a sentence, you can just say 30 feet, but that's what we're finding. The height of the tree is 30 feet. Congruent figures. If corresponding sides of two similar figures are the same length, the figures are congruent. Corresponding angles of congruent figures have the same measure. So congruent actually stands for same. That's what congruent stands for. So if you're talking about congruency, you're talking about the same. So if you have triangles ABC and similar triangle ABC that are congruent, we can determine some stuff, because determine or congruent means same. So let's find the length of AC. Well, AC is here. So let's look to the other triangle for AC. Oh, we do. We have it. It's 13. So AC is 13. That's what congruent means. They're the same triangle. They're flopped over and they look different, but they're not different. All right, now we have to find the measure of angle CAB. So see the letter in the middle? That's actually the angle. So we're going to go to angle A. So angle A, let's look for the other A. Oh, we have it. It's 60. So the measure of angle CAB is 60 degrees. You know what? Go ahead, pause it. Pause it and do C. All right, let's do C together. So ACB, the letter in the middle, is the angle. That's actually the vertex of the two sides that come together. So let's go to angle C. Now let's look to the other triangle, see if there's C. Ah, there is. It's 50 degrees. So the measure of angle ACB is 50 degrees. Quadrilaterals are four-sided polygons, the sum whose interior angles is 360 degrees. Quadrilaterals can be classified according to their characteristics. So you have a trapezoid, two sides are parallel. A parallelogram, opposite sides are parallel, and they're the same length. A rhombus, that's just a diamond. It's a parallelogram that's square. A rectangle, opposite sides are parallel, opposite angles, and all angles are the same. And you have a square, which everything is the same in a square. Those aren't supposed to be there, those triangles. All right, example 4, angles of a trapezoid. Trapezoid ABCD is shown. Determine the measure of an interior angle X and the exterior angle Y. So anytime we need to find an interior or exterior angle, we need to know all of it on the inside. Now, because this is a quadrilateral, there's 4 sides, I know that it equals 360 degrees. But let's say we forget that. So we need to figure out how many sides it all equals. So this is 4 sides. So that's 4. So we're going to use that formula, n minus 2 times 180. So 4 minus 2 times 180. That's 2 times 180, which is 360 degrees. It's 360 degrees because a rectangle or a quadrilateral that's 2 triangles. And a triangle is 180 degrees, if you're ever wondering why. So if we know one of them is 360 degrees, we can find the remainder of them. So we know that all the angles add up to 360. Now, this is not a regular polygon. This is not regular, so we can't just divide by 4 sides because each of these are different. So we know all the angles equal 180 degrees or 360 degrees. So that means angle A plus angle B plus angle C plus angle D equals 360 degrees. So angle A is 130. Angle B, that's 90. That little box means 90. Angle C is 90. And angle D, we don't know. It's X. We combine like terms. 130 plus 90 plus 90. We get 310 plus X equals 360 minus 310. And we get X equals 50 degrees. So that means this interior angle of X is 50 degrees. Now we have to find the exterior angle. Regardless the size of the shape, if you know the angle next to it, they're always supplementary. So that means for B, these 2 angles, when you add them up, it's going to equal 180 degrees because one's interior, one's exterior. So we know X plus Y equals 180. Well, we know X, it's 50. We subtract by 50, and we get Y equals 130 degrees. A triangle can be formed by drawing line segments on a map of Texas connecting the cities of Austin, Houston, and San Antonio. If the actual distance from Austin to Houston is approximately 160 miles, use the lengths of the map. We're going to find the actual distance from Austin to San Antonio and San Antonio to Houston. So they gave us a piece of information. They gave us Austin to Houston is 160 miles. Let's find the distance from Austin to San Antonio. So Austin to San Antonio is right here. We know it's an inch, but that doesn't really help us. We want to know the real distance. So what you need to find always goes on top. So what we need to find is the actual from Austin to San Antonio. I'll put SA for San Antonio. Since this is a fraction, we set it up, since this is a proportion, we set it up as a fraction. So the actual goes on top. So if actual is on top, we need another actual on top. And we know an actual distance. We know the actual distance from Austin to Houston. So actual is on top. That means what we're going to reference is the map. That's what's going to go on bottom. So on the map, Austin to San Antonio is 1 inch. So since the map needs to be on the bottom, we need to know the map distance of Austin to San Antonio, and then we need to know the map distance from Austin to Houston. So the actual distance, we don't know, that's X. Over the map distance from Austin and San Antonio, that's 1 inch. The actual distance from Austin to Houston is 160 miles. And the map distance from Austin to Houston is 2 inches. So we cross multiply, we get 2x equals 160, divide by 2, we get x equals 80 miles. So that's actually true. From Austin to San Antonio, it's actually about 80 miles. All right, let's do the same thing for B. So for B, we need to find the actual distance from San Antonio to Houston. So that's what we're going to put first because that's what we need to find. So then, if it's the same setup, we have actual on top, map on bottom. And we have the map distance. The map distance between San Antonio and Houston is 2.5 inches. And then you're going to use what you already used. We already used this information, so let's use it again. Anytime you're using proportions, use what you've already used. It makes your life easier. All right, the actual distance from San Antonio to Houston, we do not know, so we're going to say that's y. We don't say x because we already said x was something. The map from San Antonio to Houston is 2.5 inches. The actual distance between Austin and Houston is 160 miles. The map distance between Austin and Houston is 2 inches. We cross multiply because these are proportions and similar figures. We get 2y equals 160. Sorry, not 160. That was 160 times 2.5. We get 400. Divide by 2, and we get 200 miles.